Again, the series aiding can be in some other way also. Like this also they can give. Okay, say suppose one dot here and another dot here. Okay, so whenever the current comes here also the current, the dot is like at the leaving terminal, here also at the leaving terminal. Okay, so if this is the case, then also please mute your mics all. Okay, so like this, if it is like this, then also you'll get series AD. Okay, so that means either it should be at the entering terminal or it should be at the leaving terminal. Okay, again, if it is a mixed case, then you'll get minus. Okay, so now again here also you will get L equivalent as L1 plus L2 plus 2M only. Okay, again the second case is series opposition. Series opposition. Okay, so in the first one, it is in the entering phase. Okay, it is in the entering phase. In the second one, it is in the leaving. It is like this. Okay, so if they give like this, then one is at the entering terminal, another one is at the leaving terminal. Okay, then the minus sign will come. So that means L equivalent is equal to L1 plus L2 minus 2M. Similarly, if it is given like this, the first one is at the leaving terminal, the second one is at the entering terminal, again there is the mismatch. Again here also you will get negative only, L1 plus L2 minus 2M. Okay, so this is the concept. Again, sometimes this is very simple method, simple dot convention. Sometimes if you have more than two, okay, then you may have many mutual inductance. Okay, if there are more than two inductor, you may have a more than two mutual inductance. Okay, many more mutual inductance. Then that time you should know how to solve. Say we'll problem. Sir, சொல்லுங்க சார். சொல்லுங்க.
Series opposition வந்து m minus m சார்.
ஆமா சார், minus m அதனால minus 2m னு போட்டுக்கனேன்.
சார் இது plus m சார், இது minus m.
இல்ல சார், இதுவும் minus 2m தான். இங்க பாருங்க, இதுல வந்து லீவ் ஆகுது.
சார் இது இங்கே சொல்லுங்க சார். ஃபர்ஸ்ட் ஒன் series opposition.
இது சொல்லுங்க.
இது entering ஆகுது, இது leaving ஆகுது.
ஆமா, ஆப்போசிட்ல இருந்தா minus m. சார் நம்ம வந்து m வந்து பிளஸ்ல வந்தா ரெண்டுத்துக்குமே பிளஸ் தான் வரும், மைனஸ்ல வந்தா ரெண்டுத்துக்குமே மைனஸ்ல தான் வரும். நீங்க அந்த கரண்ட் என்ட்ரிங் லீவிங், அதாவது நீங்க அந்த என்ட்ரிங் லீவிங்கே விட்டுருங்க. இப்ப இங்க கவனிங்க சார், ரெண்டுமே என்டர் ஆகிற இடத்துல இருந்தா பிளஸ் சார். ரெண்டுமே என்டர் ஆகிற இடத்துல இருந்தா பிளஸ். அது போல ரெண்டுமே லீவ் ஆகிற இடத்துல இருந்தாலும் பிளஸ் தான். ரெண்டுமே ஒரே மாதிரி இருக்கு சார். அந்த டாட் நோட்டேஷன் வந்து ரெண்டும் ஒரே மாதிரி இருக்கு. இங்க லீவ் ஆகிற இடத்துல போட்டிருக்காங்க, இங்கேயும் லீவ் ஆகிற இடத்துல இருந்தாலும் ஒரே மாதிரி இருந்தா பிரச்சனை இல்லை, பிளஸ். வேற வேற மாதிரி இருந்தா மைனஸ். ஒன்னு என்டரிங்ல போட்டு ஒன்னு லீவிங்ல போட்டா அந்த இடத்துல நம்ம மைனஸ் போடுவோம். இப்ப இங்க என்டர் ஆகிற இடத்துல போட்டு இங்க லீவ் ஆகிற இடத்துல போட்டிருக்காங்க, அதனால மைனஸ். இங்க வந்து லீவ் ஆகிற இடத்துல போட்டு என்டர் ஆகிற இடத்துல அப்படி போட்டிருந்தாலும் நம்மளுக்கு மைனஸ் தான். ஓகே சார். ஓகே, 1 or 2 ப்ராப்ளம் சால்வ் பண்ணுங்க சார், அதுக்கப்புறம் ஓகே புரியும். ஓகே, now we'll take one example problem. Now there are 3 inductors. This is 10, again 10. You have to find out the equivalent inductance value. Again, there is a mutual inductance between the, say for example, L1, L2 and L3. Okay, between L1 and L2 there is a mutual inductance 2. Between L2 and L3 again there is a mutual inductance of 2 value. Okay, between L1 and L3 there is the mutual inductance. Okay, again, okay, like this is the mutual inductance. First procedure is, first you go, you write the self inductance first. Okay, what is the self inductance value here? The self inductance here is 10. Okay, you first write the 10. Okay, then next from this, okay, first you go one by one. Now you concentrate on this dot. Where this dot is going, it is going here. Okay, now where is the dot? Here this dot is like entering, this dot is also like entering, that means this is +2. okay, இதனுடைய கான்ட்ரிபியூஷன் வந்து என்னது +2. இதுவும் என்டர் ஆகிற இடத்துல இருக்குது. ஓகே, நான் ஏன்னா 10 எழுதிட்டேன், அதுக்கப்புறம் இந்த 2 நேச்சரை பாக்குறேன். இந்த 2 வந்து 2 டாட் இங்க வருது, இந்த டாட்டும் என்டர் ஆகிற இடத்துல தான் இருக்கு, இந்த டாட்டும் என்டர் ஆகிற இடத்துல தான் இருக்கு. மத்த எதை பத்தியும் கவலைப்படாம ரெண்டுமே ஒரே மாதிரியா தான் இருக்கு, எதுவும் மிஸ்மேட்ச் இல்ல. மிஸ்மேட்ச் இல்லைன்னா +2. இப்போ எடுத்த உடனே +4 எல்லாம் போட்டுறாதீங்க, +2. ஏன்னா நம்ம அடுத்து போகும்போது அடுத்து பார்ப்போம். ஃபர்ஸ்ட் இதை முடிச்சிருவோம், L1 முடிச்சிருவோம். ஓகே, L1ல வேற என்ன டாட் இருக்கு? இந்த டாட் இருக்கு. இந்த டாட் எங்க போகுது பாருங்க, இந்த டாட் வந்து இங்க வருது. ஓகே, இதுல இருந்து வர டாட் இங்க வருது. இப்போ இது என்டர் ஆகுது, இந்த டாட் வந்து என்டர் ஆகிற இடத்துல இருக்கு. பட் ஆனா இங்க இருக்கிற டாட் வந்து லீவ் ஆகிற இடத்துல இருக்கு. அப்போ கண்டிப்பா என்ன வரும்? மாறி வருது. அதனால வந்து என்னது -2. இப்படிதான் போகணும். ஃபர்ஸ்ட் இப்ப நான் L1 முடிச்சிட்டேன். அடுத்தது எங்க போறேன்? L2க்கு போறேன். L2க்கு போகும்போது L2 உடைய ஒரிஜினல் வேல்யூ என்னது? 10. அதை ஃபர்ஸ்ட் எழுதிருங்க, ஒரிஜினல் வேல்யூ 10. இப்போ அங்க இருக்கிற டாட்டை பாருங்க. இந்த டாட் எங்க போகுது? நம்ம ஏற்கனவே இங்க இருந்து பார்த்தோம்னு சொல்லாதீங்க, அங்க இருந்தும் பார்க்கணும், இங்க இருந்தும் பார்க்கணும். புரியுதுங்களா? ஒரே பாத்துல முடிஞ்சிடாது. இங்க இருந்து இங்க வந்திருப்பீங்க, பட் ஆனா திரும்பவும் இங்க இருந்து நீங்க இங்க போகணும். அப்போ L2 மட்டும் பார்க்கும்பொழுது L2 10 எழுதிட்டீங்க. அடுத்தது இங்க இருக்கிற டாட், இந்த டாட் எங்க போகுது? இங்க வருது. அப்போ இந்த 2 டாட்டுமே என்டர் ஆகிற இடத்துல தான் இருக்கு. அதனால என்னதான் வரும்? +2 தான் வரும். அதனால என்ன வரும்? +2. அடுத்தது அந்த L2ல இருக்கிற அடுத்த டாட்டை பாருங்க. அடுத்த டாட் இங்க இருக்கு, அது எங்க போகுது? இங்க வருது. இப்போ இதுவும் என்டர் ஆகிற இடத்துல தான் இருக்கு, இந்த டாட்டும் என்டர் ஆகிற இடத்துல தான் இருக்கு. அதனால இந்த 2 நான் +2 எழுதிக்குவேன். ஓகே, இப்போ அடுத்தது L3க்கு போங்க. L3 உடைய ஒரிஜினல் வேல்யூ என்னது? 10. ஒரிஜினல் வேல்யூ 10. அதுல இருக்கிற டாட்டை கான்சன்ட்ரேட் பண்ணுங்க. இப்போ இந்த டாட் L3க்கு போயிட்டோம். L3ல இருக்கிற ஃபர்ஸ்ட் டாட்டை பாருங்க. இது என்டர் ஆகிற இடத்துல தான் இருக்கு, இதுவும் என்டர் ஆகிற இடத்துல தான் இருக்கு. அதனால +2. அடுத்தது L3 உடைய இந்த டாட்டுக்கு வாங்க. இங்க இருந்து எங்க போகுது? ஃபர்ஸ்ட் ஒன்னுக்கு போகுது. ஸோ அகைன் இது லீவ் ஆகிற இடத்துல இருக்கு, இது என்டர் ஆகிற இடத்துல இருக்கு. அதனால -2. ஸோ இப்போ இது எல்லாத்தையும் போட்டீங்கன்னா கடைசியா உங்களுக்கு வந்து எஃபெக்டிவ் ஆன்சர் வந்துடும். இதுதான் வந்து 34. ஓகே, நீங்களே இது போல ஒரு நிறைய லூப் இருக்கிற ப்ராப்ளமா எடுத்து சால்வ் பண்ணுங்க. ஒவ்வொரு லூப்புக்கும் 2 முறை ஆன்சர் எழுத வேண்டியது வரும். ஒவ்வொரு லூப்புக்கும் 2 முறை ஆன்சர் எழுத வேண்டியது இருக்கும். அதுக்கு பார்த்து கரெக்டா எழுதுங்க. அகைன் இன்னொரு ஷார்ட்கட் என்னன்னா, ஒரு லூப்புக்கு நீங்க +2 எழுதினீங்கன்னா அடுத்த முறையும் அது +2 தான் வரும். அடுத்த முறையும் அது +2 தான் வரும். அதுவே ஒரு முறை -2 எழுதினீங்கன்னா அடுத்த முறை அதே லூப் வரும்போது -2 தான் வரும். எது வந்தாலும் ரிப்பீட்டடா தான் வரும். ஏன்னா இங்கே பார்த்தோம்ல, இங்க பார்த்த மாதிரி தான் வந்தா +2m, அதான் ஒவ்வொரு லூப்பும் 2 முறை தான் வரும், 2 முறை வரும். இது போல காம்ப்ளிகேட்டடா இருக்கும். ஓகே, ஸோ அது வந்து பார்த்து போடுங்க. ஓகே, ப்ளீஸ் வெயிட் ஃபார் எ மினிட். ஓகே ஓகே, ஸோ நெக்ஸ்ட் parallel காம்பினேஷன். ஓகே, ஸோ இப்போ இது போல மியூச்சுவல் இண்டக்டன்ஸ் இருக்கு. அடுத்தது ஓகே, இது L1, இது L2. ஓகே, நவ் ஜெனரலா உங்களுக்கு தெரியும் L1 L2 வரும்போது வாட் இஸ் த மியூச்சுவல் இண்டக்டன்ஸ். ஜெனரலா மியூச்சுவல் இண்டக்டன்ஸே தரலனா வாட் இஸ் த ஈக்குவலன்ஸ் வேல்யூ? வெரி சிம்பிளி L1 L2 minus L1 plus L2. வெரி சிம்பிளா இப்படிதான் வரும். ஓகே, L1 L2 divided by L1 plus L2. Okay, again because of the mutual inductance, again this formula will be modified. Okay, because of the mutual inductance this formula will be modified. Okay, how it is getting modified? First, suppose for example here dot is there, here also dot is there. Again now also you follow that notation. Here also like entering, here also like entering. Okay, both are like in the entering terminal. Okay, again we have one experience there. When both are like it is like entering, then our mutual inductance is high because of this term L1 plus L2 plus 2m is coming. So that means the finally the mutual inductance value, sorry, finally the equivalent inductance value increases. Okay, because if mutual inductance is not there, it is simply L1 plus L2. But because of the mutual inductance aiding, this L equivalent increases by the factor of 2m. Okay, now again here also if you see, now what will happen because of this one, or otherwise the other combination also we can take. Okay, this is something like we can also take like this. It is like one is at the entering, another dot is at the leaving terminal. Now this is the mutual inductance between these two. This is L1, this is L2. Okay, so if this is the case, then again what we will get here. Okay, so again this is L1 L2 divided by L1 plus L2. Again the formula will be modified a little bit. Okay, so again once if you concentrate on the numerator, again first of all you should know which combination will produce more equivalent inductance. Okay, either this one or this one. Okay, first is like as addition, this is like opposing. Okay, it is in the opposite way. Then which one will increase, which one will decrease. Okay, anyway for both the numerator remains the same. For both the numerator remains same. This is m square only. For both the numerator remains same, m square. Here also m square. Okay, and again I have to use 2m in the denominator. Again that may be plus 2m or minus 2m. Okay, one will have plus 2m, another will have minus 2m. Okay, then which one will have plus 2m, which one will have minus 2m? Very one simple idea I am telling. Okay, this value, okay, this L equivalent value, first combination will be greater than the second combination, because this is like aiding. Okay, it's like aiding. So equivalently finally the first combination will have more equivalent resistance compared to second one. Then we have to use this 2m in the denominator. So which one I have to use, plus 2m or minus 2m? Anybody? Minus 2m. Okay, very clearly that is minus 2m, because if you want more, the denominator has to be less, then that is minus 2m, then this is plus 2m. Okay, so this is the final formula. Again there are derivation and proofs are there, but not required. Okay, simply you can remember the formula and make sure that whether is it following the unit convention. Henry into Henry minus Henry square. Okay, Henry plus Henry minus Henry. Okay, Henry square minus Henry square is Henry square. Henry, then finally Henry. Is it following the unit convention or not? It will follow. Okay, it will follow. That's why if you have any doubt in the future, see what doubt you will get finally. Either this is minus minus or plus plus, that doubt you will get. Or otherwise this 2m will go up or m square will come down. Okay, that doubt you should not get, because as per the unit concept, if this is L1 and L2 means here it has to be m square, not 2m, because or otherwise if you take the different manner, then unit will not satisfy. But you have to remember this, the numerator is same for both, but the denominator is here minus, here plus, because it has to produce more value. That's why here minus, here plus. Okay. Next we'll solve some problems. Okay. Four millihenry, 6 millihenry, 5 millihenry, 2 millihenry. This one is 10 millihenry. Okay, yes. Now how to proceed? You go from one by one. Okay, the L equivalent value solution. L equivalent. First you write the absolute inductance value L1, that is 4 millihenry plus. Okay, here dot is there. Where it is going? It is going here. This is like entering terminal. This dot is also entering terminal for this inductance. Okay, because they have mentioned here, this is for this inductance. Okay, this is entering, this is also entering. That means this value is plus 10. That means this value is plus 10. Okay, so one thing is over. Okay, next you concentrate on this 6 milliampere. Okay, you simply write 6 millihenry. Okay, again where it goes here. Here it is leaving, here it is entering. So opposite. That means 2 means minus 2. Okay, 2 means minus 2. Okay, and then next you concentrate on this one, 5 millihenry. Okay, here the absolute value is 5 millihenry. Okay, 5 millihenry. But again here the dot goes to two places. Okay, one is this one. Okay, here entering, this is leaving. That means minus 2. Again this dot also goes here, but this is plus 10. Okay, this is plus 10. Okay, so finally what is the value? Answer is 31 millihenry. Answer 31 millihenry is the answer. Okay, we'll take another problem. Okay, this is 2 Henry, dot is here, 2 Henry, another dot is here. This dot and this dot is related with the 1 Henry, and here and here another dot is there. This is related by 2 Henry. This value is 3 Henry. This is 4 Henry. Now what is the value? Okay, so one by one we have to go. First you concentrate on the parallel network. Okay, once if you solve this, then again you can make it as a series, then again you can concentrate on the remaining things. Okay, at a time also you can do no problem, because this dot is not going here, it is straight away, it is going here. So first you concentrate on this network. Okay, like a parallel network. Okay, so parallel network, if you concentrate on a parallel network, first I am concentrating on the parallel network. What is the L equivalent for parallel network? Okay, so what is the answer? Okay, so one is at the entering, another one is at the leaving. Then what formula I have to use? L1 L2 minus m square L1 plus L2 plus 2m formula I have to use. Okay, so this is the formula. So what is L1 L2? 12. Again m value is 2, 4. L1 L2 is 7, and then 2m means 4. So this value is 8 by 11. This value is simply 8 by 11. Okay, again now this entire value is like 8 by 11. Okay, now I will find out the final L equivalent final. Okay, where 2 Henry is there, where is the 2 Henry going? The mutual inductance from this one is going here. Okay, here like leaving, here also like leaving. That means I have to take this plus 1. Okay, plus 1. Next you write the parallel network value. The parallel network value is simply 8 by 11. Okay, then you concentrate on this 2 Henry. That 2 Henry value is this is simply 2, but the dot is there. Where is the dot going? The dot is going here. Here leaving, here also leaving. Then that means plus 1. Okay, once if you add all this, you will get the final value. The final value is 74 by 11. 74 by 11 Henry. Okay, so this is the answer. Oh, so next one is ideal transformer. Ideal transformer. Okay, if the transformer is there with turns ratio N1 and N2, M is the mutual inductance between the primary and the secondary. Again, you know, we have derived one equation, the mutual inductance M is equal to K L1 L2. But if it is an ideal transformer, the K value is 1. K is equal to 1 for ideal transformer. K is equal to 1 for ideal transformer. Already we have seen K is equal to 1 for ideal transformer. Then what is its simplification? What is its implication? Okay, what do you mean by the ideal transformer? Okay, the transformer is ideal means it is not having any losses. Generally, the transformer will have many loss. core loss, copper loss, something like that. There will be many loss, heat loss, something like that. Okay, so if it is ideal, then it will not have any loss. Okay, so no loss. Again, the efficiency is like 100%. When the loss is not there, efficiency is like a 100%. Again, rest of the equations are same. Again, when k is equal to 1, again you can write m is equal to L1 square root of L1 and L2. So that means m square means simply L1 and L2. Okay, so this is the relationship. Okay, for the ideal transformer. Okay, so again, we'll see mutual aiding. Mutual adding, mutual. Okay, suppose if the transformer is like this, so this is I1, I2. Okay, mutual inductance between the transformer is M. Okay, again dot is here. Okay, so whenever we solve the electrical circuit, okay, then how to represent this structure? Okay, so that we can easily write in the electrical circuit format, and again we can apply KVL, KCL, because once if it is like this, you cannot apply KVL, KCL combinedly. You can apply separately, but the problem is here mutual inductance is there. Okay, then so once if you write the formula directly, say this is V1 and V2. V1, okay, the voltage at the primary depends on finally L1 di1 divided by dt, but also with M mutual inductance, M di2 divided by dt. Okay, see, if the mutual inductance is not there, V1 simply depends on L1 di1 divided by dt, but because of this mutual inductance, V1 also depends on M and the current variation at the coil 2. Okay, it also depends on the mutual inductance, M di2 divided by d2. But again, it depends on how much mutual inductance. Even though the mutual inductance is there, then what is important? There should be the current variation at the coil 2. Okay, if you have some effect at the coil 1 due to coil 2, then there should be the current variation at the coil 2. And again, the format is like this. Okay, M di2 divided by dt. Similarly, V2 depends on L2 di2 divided by dt, and also depends on M and the current variation at the coil 1. Current variation at the coil 1 in general. So that this diagram can be represented like this. Okay, so I'll write in the next page. Okay, this diagram can be modified like this. In the T structure format, you can write like this. Okay, so this is I1, this is I2, this L1 minus M, this is L2 minus M, this is plus M. Okay, so okay, so this is mutual inductance. Okay, so again, this you can write like this: L1 minus M in this branch, here L2 minus M in this branch, but here plus M. Okay, here plus M. Okay, now again you apply the I1 current is flowing here. Then what is the current here? This is I1 plus I2, because I1 is coming from this way, I2 is coming from this way. Then both they combine together. Then it will flow through this branch only. This is I1 plus I2. Now you apply the KVL, KCL. Okay, you can easily apply the KVL. This is V1. This is V2. You apply the KVL and KCL. Okay, so once if you apply the KVL here, V1 is equal to L1 minus M di1 divided by dt, okay, plus M di1 divided by dt plus di2 divided by dt. Okay, once again, if you multiply inside, finally you will get V1 is equal to L1 di1 divided by dt. This M di1 by dt will cancel with this one. Okay, so you will get M di2 divided by dt alone. So again, you can compare with the previous equation. V1 means L1 di1 divided by dt, M di2 by dt. So this is same as the previous equation V1. That means what? If the structure is like this, if the dot convention is like this, like AD, you can replace that diagram like this in the T format. Okay, so that your circuit analysis will become simple. Similarly, you can write KVL at the secondary side. Okay, again you will get V2 is equal to L2 di2 divided by dt and m di2 di1 differentiation of I1 with respect to t. Okay, so and similarly you can extend this for mutually opposing also. Okay, so if it is mutually opposing, one dot is here, the other dot is here, then this is mutually opposing. This is I1, this is I2. Then you can write this one. The structure remains same, but the values differs little bit. Okay, here instead of minus m, you will get L1 plus m, but here instead of plus m, you will get minus m. Here L2 plus m. Okay, again you can apply the KVL and the KCL. Okay, you can prove that both the equations are same. So what is the equation? VL di1 divided by dt, because this is opposing. Okay, the dot convention here, one is entering, one is leaving. That's why I put minus here, m di2 divided by dt. Here also V2 L2 di2 by dt minus m di1 by dt. Okay, again you can apply the KVL, KCL here. Once again you can prove this. Okay, both are same as V1 and V2. You can apply KVL and KCL here. So this is the equivalent circuit model for a transformer. Okay, so again we'll see one more concept, final concept, the load reflection at the primary side. Load reflection at primary side. Okay, suppose if you have a transformer like this, this value is like RL, load resistance is there. Again, this is I1, this is I2, this is N1, and this is N2. Okay, now the resistance looking from this terminal is RL. Then what is the resistance value looking from this terminal? That we have to calculate. Okay, so that means what? The same circuit I can put like this with some source. Okay, I1 current is flowing. Okay, and again, what is the effect of RL at the primary side? Okay, so I can equivalently map like this. Okay, say for example that some new value is there, that is RL dash. Okay, that is RL dash. Okay, so the RL dash value depends on N1, N2 whole square into RL. That means what? The load reflection at the primary side. This is mainly used for circuit analysis purpose. Okay, what is the effect of this load at the primary? Okay, once if you know this, because once if you do like this, you can calculate I1. Okay, once with the help of this formula, you can calculate the I1. But once if you know I1, you can easily calculate I2. That is the idea of this reflection. Okay, what is the effect of the load at the primary side? Okay, it depends on N1 and N2. Okay, irrespective of the value of N1 and N2, N1 may be greater than N2 or N2 may be greater than N1, but this is the general formula, how the load will be reflected to the primary side. Okay, RL dash is equal to N1 divided by N2 whole square into RL. Okay, so in the next class we'll solve few problems based on this formula. Okay, the next we'll go to the transients. Okay, so with this I will stop. If you have any doubt, you can ask.